Hello, my name is Jericho Matthew, and I'm presenting on behalf of me and my group mates Leong Ken and Deric Wong from Universiti Tunku Abdul Rahman. Our project is titled Algae Control Using Microbial Activator in UTAR Lake 19, a field-scale evaluation of a microbial-based treatment for sustainable lake water quality management. Eutrophication is one of the most common threats facing freshwater lakes today. Excess nutrients trigger algae blooms, which deplete oxygen and throw entire ecosystems out of balance. Conventional treatments like chemical algicides are often costly and environmentally disruptive. Now, UTAR Lake 19, a tropical campus lake with recurring algae blooms, gave us the perfect real-world test site to trial a microbial activator. Our study had 4 objectives. First, to evaluate how effectively the microbial activator controls algal growth. Second, track key water quality parameters like chlorophyll A, total nitrogen, COD, and phosphate. Third, to compare the treated lake against an untreated control. And finally, to assess how results vary spatially, from the shoreline to open water. We selected Lake 19, about 17,661 square meters, as our treatment site. Applying the microbial activator was done by drone-based spraying at a 1 to 2 million dilution ratio. Lake 18, which is roughly 243,550 square meters, served as our untreated control. Both lakes share the same campus, climate, rainfall, and sunlight exposure. This lets us make a reliable before and after comparison. We sampled 3 sites per lake across 4 rounds from March to July 2026. Our methodology followed 4 steps. Apply the treatment by drone, sample 1.5 liters of surface water at 3 sites per lake, analyze each sample in the lab for chlorophyll A, nitrogen, COD, and phosphate, and compare treated versus control results as well as shoreline versus open water conditions. This was done to make sure our findings held up under different sampling conditions. Our methodology involves physical, chemical, and intrusive methods that are environmentally friendly. Overall, it was less laborious with a cheaper cost while showing high-quality results. A wide range of technical equipment was used to test the samples and to apply the microbe activator. Let's look at the results. Chlorophyll A, our indicator of algal biomass, fluctuated in the first 3 shoreline samplings, partly because of a brownish organic layer we observed accumulating along Lake 19's shoreline early on. But once we shifted sampling to the open water from late April onward, a clear pattern emerged. Lake 19 averaged 50% lower chlorophyll A than Lake 18 across 3 separate sampling rounds through July. The same trend held for the other parameters. Averaged across those open water samplings, Lake 19 recorded roughly 33% lower chemical oxygen demand and 27% lower total nitrogen than Lake 18, consistent with the enhanced microbial nutrient cycling and organic matter breakdown. Phosphate, meanwhile, stayed below the detection limit of 0.08 milligrams per liter in both lakes throughout the study, so it wasn't the limiting nutrient in this case. To put it simply, 50% lower chlorophyll A, 33% lower COD, and 27% lower total nitrogen in the treated lake. And this wasn't just numbers on a page. On the 23rd of April, we visually compared water samples side by side, and Lake 19's water was noticeably clearer, with fewer suspended particles than Lake 18's. This is all thanks to the microbe activator, which contains organic nutrients that activate the local microbes, causing them to compete with the local algae in utilizing nutrients. This in turn directly controls the algae blooms. This project aligns directly with the following UN Sustainable Development Goals: SDG 6, Clean Water and Sanitation, by reducing pollution load in freshwater systems; SDG 15, Life on Land, by protecting freshwater ecosystem health; and SDG 11, Sustainable Cities and Communities, by delivering cleaner water for campus and community use. More broadly, the microbial activator is a non-disruptive and natural alternative to chemical lake remediation. And because eutrophication affects tropical lakes worldwide, this approach has real potential to scale far beyond the UTAR campus. In conclusion, Lake 19 showed measurable, sustained water quality improvement over 4 months of treatment once we accounted for early shoreline variability. We recommend longer-term monitoring at a consistent open water sites to further validate these findings. Treatments should also be applied 2 to 3 times per year to maintain water quality, as prevention is better than a cure.